Yeah, hello. As said, my name is Jöran Vinzens. I live in Cologne, that's in Germany. I have about 10 years plus experience with VoIP. I started with high-pass 4000 at Siemens, getting these SIP phones ready on there. And actually, I'm a VoIP engineer and system administrator. I'm sorry. And I work with Asterisk since 2005. I used to test these open point telephones on the Asterisk. If you have any questions or like to contact me later on, please write me an email or go to LinkedIn. I'm there. I'm working currently for Sipgate. It's based in Düsseldorf, so very near to my home. It was founded 2004. It's a VoIP carrier. We offer VoIP services in Germany and in the United Kingdom. And 3 years ago, we started as mobile virtual network operator, so we can add cellular services to our virtual PBX product. At the moment, we have private and business customers. So why am I here? Earlier this year, Matt Jordan was visiting us in Düsseldorf. And he had to talk about open source software development in an agile way. If you follow that link, you can see the talk. And I think he was a little bit nervous beforehand. Just like that. He asked us, would you mind come over to Astricon and show us what a carrier-grade open source telco looks like? And we said, yeah, sure. But I had no idea where to start. So I thought about, and the beginning might be a good start. So the beginning was 2004. Yeah, you don't see the headline. It says Sipgate in 2004. It was pretty much that. We had a couple of Asterisks, some Kamailios, or earlier it was OpenShare, and some zip phones in the internet. Oh, thanks. The Asterisks, we had a little problem because we had no clue what it is to be a carrier. So we just connected them with PRI to local networks. So we get local numbers from the local networks, and so we had to spread the Asterisks out through Germany. And this is quite a pain in the ass, because you need, in every local area with a prefix, you need an Asterisk server. And this was not the real way. But we started that. The Asterisk gateways looked like that. We had a couple of Asterisks with PRI connected, getting ISDN channels from the carrier or sending to the carrier. Then there was a bunch of AGIs behind, connecting to databases, getting information about billing, about who's a customer, who's get called, whatsoever. And then the call gets forwarded with VIP to the Kamailio. The Kamailio on this part gets a call, gets to the database, shows the location of the user, where it is registered from, and sends out the call to the internet. Or the other way around, call comes in or registration comes in, checks if the user is valid, and sends forward to the gateway. So that's pretty much it. It's, I would say, the most basic setup you can have with Kamailio and Asterisk. Then we thought, we have to work on this PRI stuff. So we got an SS7 Interconnect with Deutsche Telekom, and since we are not in the shape to talk SS7 on the Asterisk or earlier that time, so we bought us our black box from Teles, where SS7 comes in on the one side and PRI got out on the other side. So we don't need to change anything on our side. Just put that box in there. It was 5 shelves of metal. Huge for doing nearly nothing. So, some pictures. This was Sipgate 2004, a little bit later. A weird bunch of cables all over across, and no real good picture. From there, we thought we have to protect our system more than we do now. And we established a second bunch of Kamailios, which are stateless. So they do not know the state of a call, just protect our network from the outside. As my predecessors talked about, there's a pike and pipe module which can protect our own network from the internet. So if there's some script kiddies getting with lots of registers to us, we can just block them.
If you can catch them.
Yeah, sure. It looks like that. It's pretty easy. Both sides zip. The phone connects to an UDP Anycast IP address, so it doesn't matter if the system is or if one system is down or not. It just catch any of those systems, and the call gets forwarded to a proxy. From there, we thought about 2006 it might be a good idea to add some features to that system, and to offer maybe to a more professional, so to get to some more professional customers. So we added some, my LibreOffice just crashed, but from there we added these second bunch of asterisks, which makes a lot of handling regarding PBX functionality. So it looked like that. We had this Kamailio on the one side, getting calls in and out from the phones, sending via zip to the asterisks. On that asterisk, there were local fast AGI running and daemon server connected with AMI, and it's pretty much hosted PBX. So everything you want to have in PBX, we added there. And back in that time, we dealt a lot with analog phones. So we dealt that time a lot with analog phones connected to a zip adapter, and we want to add these features also for that devices. We used DTMF codes to put the calls on hold.
Don't worry about that.
A bit annoying. So pretty much the PBX features is done there. This worked for about a year, and then the daemon AMI stuff just collapsed because too much traffic for too less power. So we clustered that a little bit and duplicated this one system lots of time, so we can scale. The routing is done for each customer. So we have customer number-based routing there. So each customer gets each phone calls, each devices to the same system. So from there, we thought it might be a good idea to not only rely for wholesale on this TLS switch and outgoing carrier, and added some zip carrier to that. For that, we just made some contract with some external zip carriers and made some adaptation to the Kamailio server to not block 3 parallel calls for one peer. So we fall over that once, was found very fast. This is pretty easy. It's just a zip carrier, a bunch of Kamailios, and our proxy. From there, we thought we don't want to have this TLS switch anymore. It's too much metal, too high power consumption, and not flexible, and we have no control over the entire SS7 stuff. There we get the first contact with Yate. This was about 2010. This looks like that. We have the Yate getting SS7 on the one hand via SCTP, speaks zip on the other side into our network, and controls an MGCP or media gateway via MGCP. And this bridges the ISDN circuits to RTP in our network. This is pretty much it. So it's no voodoo. As of 2010, we shifted our entire hardware to co-location data centers, and now it looks like that. So it's much cleaned up. So at that time, wrong sheet. we added some more features to that, which is this part here. We thought it might be a good idea to connect to many carriers in Germany to not get only calls into our network just by the Deutsche Telekom. And so we created a new company which connects to to many other carriers to exchange traffic directly. This is a win-win-lose situation. So we win because we get more fees from the outgoing for the giving carrier. The giving carrier, it's a win situation because they pay less to us, and lose for the Deutsche Telekom because they don't see the call anymore. It's fine for us. This is how we build it. We have several carriers connected with ZIP to stateless Kamailios. From there it goes to stateful Kamailios because they control RTP engines. This we have put in between the RTP stream to cover up for the architecture behind. We don't want to see what's behind, or we don't want to have our customers see that we get this call from another carrier directly from whatever. After that, we have a Yate. This is because we had made some good experience with the other interconnect. We used that here as well as a back-to-back user agent and to write CDRs because we want to charge the incoming carrier for that. As well, we have a database on that. In this case, it's MySQL, just to clarify if this carrier is allowed to send traffic to that certain carrier. From that, it got a little bit difficult, we thought it might be a good idea to extend our what we can offer the customer, and we got MVNO. So mobile virtual network operator. This was a quite huge step. We had experience with SS7, but just the ISO part. We have no ideas that time with the entire mobile stuff. So we just made it. We talked with the Nalro guys for the Yate, and they told us what we need to buy and what we have to make in contracts and which RFCs we have to read on whatever. At the end, it looks like that. We have written our own HLR and SMSC. This is a Java process which is connected to our backend and getting all information it needs from our existing backend, like which customer we have. And we added a bunch of SIM cards information like the IMSI, mobile number, whatever. We put all in there, and the HLR and the SMSC get information from the backend. The Yate, it's not exactly this picture. It's two Yates, one STP and one SEP. It's SS7 things, but for made it more easy, I just put it there. It's a Yate getting XML on the one side and speaking SS7 map and camel to our network operator. As well, we had in the other interconnect before, we have this SS7 ISOP and AZIP channel bridging. We have media gateway we controlled via MGCP, bridging ISDN circuits to RTP channels. So that's pretty much it. It's a little bit compressed now, but this is how we got MVNO. So from there, this is the state as today. So this is where we are. So the question we had back in 2004, how do we want to make routing decisions? How do we want to know which call is to send where and which number is assigned to which customer? So we wrote our own routing engine. We use Perl for that. It's DNS based. This is pretty easy because there are some modules in the Kamailio where you can just give me the enum request for this number, and it turns the number around, makes some points in the middle, and send it back to the DNS, makes an NRPTA request. And on our own server, we get this request and look, okay, it's, I don't know, internal number, so we have to set it internally or externally, whatever. So for the carrier routing, it's pretty simple. We route on prefix or on LNP, LAC based. I don't know if this is known, LAC and LNP. Yeah, correct. So if we have a contract with a carrier, we try to directly send the call through there and not through wholesale. This spares us money and the receiving carrier. For the most of the carriers, we don't have direct access to that carrier, so we can't do that. We call them through wholesale, and for international calls, depending on who's the best price. So for internally routing, as I said before, the hosted PBX part, we need calls from one customer on one cluster. So this is based on customer, which customer number is routed to that certain cluster. And for all other things, it's random. So we don't care which gateway a call hits because they all do the same. So coming to monitoring. Monitoring is an issue for itself. A colleague of mine held a talk on the open source monitoring conference, explaining how we do monitoring, especially with Kamailio and Asterisk. And this would explode my talk. So if you just refer to that link, you come to the YouTube video of this call. We do monitoring, and I want to talk about that, which is not eSING Nagios or CACTI. For signaling, we use Humor. Tomorrow evening, there is a call about Humor, so it's very interesting. You should join that. And for RTP, we use VoIP Future and Extra again. This is unfortunately closed source, but I give you some screenshot later. Humor. Because Humor is quite difficult and you really have to know zip. This is not Humor, before you take some photos. This is an own written plugin for CACTI, which looks in the CDR database and searches calls. So you can search for caller line or source or destination numbers here, and then you get a line for each call. So we have when was a call, how long was a call, which customer, blah, 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 and a link for Humor. This is interesting, especially if you don't want to search in Humor directly. And this is always the case if a customer calls us, comes to the customer support, and they want to help the customer directly. So they don't want to hand off this ticket to another party. They just want to help them. So they can click by themselves on that link, and then Humor comes up and shows all related call legs for this one call. This is a basic overview about one call with us. And if you click on one call ID, there's a diagram how a call goes through our network. And if you click now on, I have no screenshot for that, I think. If you click on this invite, you can see the invite plain text. So it's very easy to find failures. For example, customer called an invalid number. He calls us and say, I can dial my mom, whatever. And we can search for the customer number and find the call, and then we can click on the Humor button, click on the call ID from the customer to us, and see, okay, you dialed bullshit. Just redial in the correct way, then it would work. Additional to that, we have made some own changes to that, where we push billing information in the Humor, which come from our backend. So if the customer has no money left for that call, our customer support can just see that in the first place and say, okay, you have to credit your account, and then you can call again. For RTP, we have two types of monitoring. One is passive and one is active. Passive RTP monitoring we do with VoIP Future. It's very, very powerful tool. You tap, or in our case, we tap on the edges of our network some machines from them. They count RTP packets. So they don't record them, they just count them. And they can tell you how was a jitter, for example, or how was a packet loss. And on that basis, we can tell the customer, okay, your ISP is crap, or yeah, you just not call over satellite telephone in data stream and so on. This is a quite bad example. Hopefully, normally we just have here a peak with 20 milliseconds delay for each packet, and that's it. So this is a minority of how the calls look with us. For the active RTP monitoring, we use a solution from Nextragen. They have probes, and they do active calls to a server within our network. This is cool stuff because we can measure the PASC value. So we don't have to guess what the MOS might be. We can just measure it. And there we can see, yeah, this is a bad thing too, because one of the probe is behind O2 DSL, and O2 DSL has a problem anymore at the moment. So these measures are crap. Good for us. We can say our customers, if you want to have an ISP, don't go to O2. So in this case. So we are always interested in expand this, and yeah, I think we have 30, 40 boxes at the moment in the field, just making calls all the time, and we measure that. Next step for us, huge step will be Asterisk 13. We have to adapt our own patches to Asterisk 13. Hopefully we get rid of them and can put them in a normal way in the Asterisk 13. And then we have to slim down the setup. Over the year, it grows very complex. And we have two different kinds of Asterisk servers. There's no need to have that. We can just put them in once. This is just one thing we want to do. And then last time I thought about virtualization, it was 2006, and in that time, it was not possible with real-time applications. We thought about that once again, and we want to have it. But we don't have it so far. Yeah, if you are interested in moving to Düsseldorf or near that, or want to help us in any other way, we hire. So, nothing else to say. So long, and thanks for the fish.
All right, questions?
Okay, I'll make it just a two-part question. First of all, what software do you use for the passive RTP quality monitoring?
Excuse me? What?
The passive RTP quality monitoring.
Yeah.
What is the software you use for that?
What we use.
You said you had the passive
yeah,
monitoring.
it's Nextragen. It's Nextragen.
So same as the active monitoring.
No, VoIP Future, sorry. The passive is VoIP Future. We have some servers from them, and we have taps which are linked in the optical fiber to the outside the world. And there we count all RTP packets.
And the second part of the question is why do you go down that route instead of having the Yate or the Asterisk, which are generating your CDRs, generate the jitter stats directly because they're in the media path?
Because we found out that we made mistakes in our own network. And as long as an Asterisk 1.6 runs, the bad the RTP becomes. And this, we can't measure that on this machine. We must have an external component measuring that. And just to eliminate our own measurement failures for the complete picture, we just want to have that somewhere else. We thought about that, getting RTCP stats in the Hummer, but it was not reliable since not all device supports RTCP. And then we get to that project.
Any more questions? All right, let's give him a round of applause. Oh, one more over here. We got time.
You also mentioned that you were using enum for routing.
Yeah.
Why do you find it easier to use enum versus a standard SQL query in the database?
That's very
For me,
good.
it sounds it's harder to update a DNS server than it is to update
Yeah,
a database.
it's not an enum server. It's our own written software. So the Kamailio goes to the DNS server. The DNS server forwards the request to our own software. And for that, it's in a database. So our own software looks in a database and gives back the request URI for the Kamailio. And back in 2004, this was the best solution we had, and it's working since then.
I just figured you could just look it up directly in the Perl script that you have.
Yeah, I think if we would do it again with the knowledge we have now, we would do it another way, but we didn't.